Okay, right. Sit down. So try to answer my question every day. This is for just for recall your previous class. So don't think about if someone wrong answer, right answer. No. You answer the question. That's it. Right or wrong is a different. Okay. You argue with that question. That is main. Okay. Right. So atomic radii, you know that atomic radii, the distance from the nucleus to outermost orbital, that is atomic radii, isolated gaseous atoms. We measure the distance from the outermost electron with that nucleus, that is atomic radii. So you know that general trend is followed for the from the left to right, decreasing, top to bottom increasing because of the principal quantum number increasing continuously, and also new orbital introduced continuously, hence the atomic radii also increasing. Okay, here today we go for the ionic radius. So ionic radius, the same concept only. Okay, ionic radius. So here ionic radius, you know the ionic radius means the same. In the isolated gaseous atom, we have to convert the atom into gaseous state. From that gaseous state, you remove the one electron. Okay, you remove the one electron or else you add one electron. So after that, you measure the distance of that outermost orbital with the nucleus, that is an ionic radius. Okay, the same. First, the metal is there, you convert into metal gaseous state. From that, you add one electron or else you remove one electron, you get it M plus or M minus. So in that molecule, you measure what is the distance from the nucleus with the outermost orbital, that is ionic radius. Okay, so for the ionic molecules, we measure the distance from the nucleus to outermost electron, that is an ionic radius. So here, what is a trend is there? The same trend only here, because there is no much difference. The same from the top to bottom, the principal quantum number increasing. When you increase the principal quantum number, definitely the new orbital is there. So therefore, the distance is increasing continuously. That is a general trend from top to bottom and left to right. Here increasing, here decreasing. Okay, this is a general trend. Am I right? First, you write the definition of ionic radius. You write it. The same definition only, but at the last end you add one electron or remove one electron from the molecules. In isolated gaseous atom, definition and all you write it, no issue, because someone given the different way. In isolated gaseous atom, isolated gaseous atom, after addition of one electron or removal of electron, after addition of one electron or removal of electron, after addition of electron or removal of one electron, then measure the distance from the nucleus to outermost electron. Then measure the distance from nucleus to outermost electron. That is called ionic radius. For example, M is there. M is there. Okay. When M means material, when M is there, you add one electron or you remove one electron, you get it M minus and M plus. So what happened when you remove one electron from the orbitals, you know. So for example, here I will explain here. Maybe you take any atom, no problem. Beryllium you take it, okay? Beryllium you take it, otherwise lithium also you take it, no issue, okay? Here you remove one electron means what is the configuration of beryllium? What is atomic number? Beryllium 4, 1s2, 2s2, then 2p1, no? Okay. So here, if you add one electron, 1s2, 2s2, 2p1. If you remove one electron, this is the addition of one electron. If you remove one electron, so what happened? 1s2, 2s1. So here, just listen. Here, when you addition of one electron, the p orbital, here there is no electron, but here p orbitals have one electron. So the electron 4 means how many number of proton? 4 electron means how many number of proton? Four electron means 4 proton. Okay, but here 4 proton is there, but 5 electron is there. 4 proton, 5 electron. But here 4 proton, 3 electron. Okay, proton is more. Think about it. The magnet is more. Less ion pieces means it is very attractive by the nucleus. Therefore, the distance is decreasing here. But here, the proton is more. Sorry, the electron is more. Proton is less. Therefore, the distance is more. Right? 4 proton, but 5 electron. Right? When you add the electron go and sit in the p orbital. P orbital. Okay, 1s2, 2s2, 2p1. Okay, and 4 proton, 5 electron. Therefore, the distance is more. Here, the distance is less because proton is more, electron is less, hence very close to the nucleus. Because number of proton is more, is attractive very effectively all the electron towards the nucleus side. Therefore, the distance is decreasing. So for what is a decreasing and increasing order of cation, anion and neutral. Okay, cation and anion and neutral. For example, this is an atom, right? This is an atom. This is addition of one electron, so anion. This is removal of one electron, therefore this is a cation. So which one is maximum radius? Which one is maximum radius? Now only I explained, right? Which one is maximum radius? Students, follow the lecture. Which one is maximum radius? Anion, yes. Anion is maximum radius, then atom. Atom and cation, which one is maximum radius? Atom. So this is a trend. Anion is maximum, then the atom. Atom is maximum, then the cation. So cation is a less ionic radius. Suppose they ask us sometimes the question, aluminum 2 plus, aluminum 3 plus, okay, F minus, what is the atomic radius? Arrange the atomic radius. MCQ question also possible, part B also possible with the explanation. Arrange the elements in the following order of increasing or decreasing. So this is a clue. Anion is more than the atom, and cation is very less. You got it? Because the anion is a excess electron than the proton. That's why we given the one example, beryllium, 4 proton, 5 electron for the anion. So more electron means the attractive force of that outermost electron is less, hence atomic radius increasing. But here the proton is more, electron is less, therefore it very effectively attract the electron towards the nucleus side, because that is a thing of with very big magnet. Right? So here for example, lithium, sodium, okay, lithium, sodium, potassium and rubidium, plus charge you can take it. Which one is maximum radius? Maximum radius. Which one is the maximum radius? The student think and say the answer. Last row, what you are doing? Which one is maximum radius? Rubidium, okay, and potassium and sodium, because this is a general trend it's followed, because from the top to bottom atomic radius increasing. This is a alkali earth metal. You know that the first S block element. Lithium, sodium, potassium, rubidium, cesium. Okay, when increasing the atomic ionic radius, because of the top to bottom it's coming, general trend. But similarly, the other example, sodium, magnesium, aluminum. Okay, sodium, magnesium, aluminum. For example, sodium plus, magnesium 2 plus, aluminum 3 plus. Here the regular trend is different because of the atomic charge of the ions is different. Na plus, Mg2 plus, aluminum 3 plus. There only the other concept we introduce, that is a isoelectronic species. Okay, isoelectronic species, which means what is a isoelectronic species? Maybe we look at here. The same, you take it. Na plus, O2 minus, N3 minus. Okay, magnesium 2 plus and aluminum 3 plus. So you can order this ions increasing or decreasing order. So here cation also is there, anion also is there. So out of that, you know the anion is a maximum radius, then the cation. That is what we discussed, right? Anion is maximum radius, then the cation. That clue you have. right? Think about it. What is a sodium atomic number? 11. Oxygen atomic number 8. Nitrogen atomic number 7. Magnesium atomic number 12. Aluminum 13. So think about it. Sodium is a 11 atomic number, plus means we remove 1 electron from the atom, therefore 10 electron. The rest of the electron in the nitrogen 10 electron. 8. 2 minus means we add the electron in the oxygen, therefore 8 plus 2 10 electron. 7 plus 3 10 electron. And 12 minus 2 plus means we remove the electron from that atom. Okay, so here also 10 electron and here 10 electron. So this is a isoelectronic species. The rest of the electron after addition or removal of electron from the molecule's atom means that electron is same, that is a isoelectronic species. So for the isoelectronic species, the size is inversely proportional to the atomic number. This is a concept. The size is inversely proportional to the atomic number. Atomic number more, the size is less. Okay, now you arrange. Which one is the first? Atomic number less means that is maximum radius, right? As per the concept. Which one is atomic number less? Out of 5, nitrogen is a less atomic number. So 7, 3 minus. That is maximum radius. Next, oxygen. Oxygen 8, 2 minus. Next, 8, then 12, 11. Sodium 11. Right? Then 12, magnesium 2 plus 12. Then aluminum 3 plus 13. So this is a maximum radius. Then oxygen, then sodium, then magnesium. This is the order of the above ions, increasing order. Okay. So atomic number less, maximum radius for the isoelectronic species. And also one more clue, anion is maximum radius than cation. So all the anion is maximum radius than cation. So here the cation is less charge, maximum radius, more charge, minimum radius. So inversely, see, maximum charge, maximum radius, but here minimum charge, less radius. Okay, that also one of the point. It means, what is it? You understood, right? So definitely they asked the question from the trends in the periodic table. Isoelectronic species, arrange the order, increasing or decreasing order. First you arrange the anion, then cation. Anion is, which one is maximum charge, that is maximum radius. In the cation, which one is minimum charge, that is a maximum radius. So for example, another example, you try to work up hydrogen, hydrogen minus, hydrogen plus. You arrange the increasing or decreasing order of this one. H minus is first, H plus is last, right? H minus, then H, then H plus. That we know already. Look at here. What is it? Yeah, anion first, then atom, then cation. So that order. Anion first, atom, then cation. Okay. That is the order. Now you come for another example. Nitrogen minus N 2 minus, N 3 minus. Now you arrange. Yeah, student, write it. Simply you are sitting and looking the mobile phone, playing the game. What is the use? I told you don't know. Till now you should not write anything. See, I am noticing your class continuously. Day by day the class is going very fast. The students not listen the class. They didn't take the notes. So I am not saying to you the notes. Don't believe the notes. You take the notes from the class. You write the notes what to listen the class. That will be helpful for you. Yeah, you arrange the anionic species N3 minus, N2 minus, N minus. What I told, the anion, right? Anion, the charge is directly proportional, right? The charge is maximum means maximum radius. Sorry. Radius directly proportional. Yes. In the anionic species, the charge is maximum means the size is more. Okay. The charge maximum, the size is more. So here maximum charge, therefore this is a maximum size. So N3 minus times 1250. Okay, 5 minutes. Not 5 minutes, more than 5 minutes. Yeah, student, try to work out S2 minus S2 minus P3 minus Cl minus. You arrange the anions decreasing or increasing order. Decreasing or increasing order. Anyhow, I given already clue for the anions. Charge maximum means size maximum. As per that concept also you arrange. So therefore the P3 is there. P3 minus is maximum, then S2 minus. S2 minus is maximum, then Cl minus. Cl minus. Otherwise that is a yeah. What is the atomic number of chlorine? If you don't know means noble gas configuration, you know helium, neon, argon. Okay, atomic number of argon is 18. So nearby means 17. So 17 plus 1 is the 18 electron. Okay, 18 electron. Then the sulfur and phosphorus. Oxygen, sulfur, you know that sulfur is the oxygen family. So therefore this is 16 electron. 16 plus 2, 18 electron. This is 15 because nitrogen family 15 electron. 15 plus 3, 18 electron. So this is isoelectronic species. Isoelectronic species, what is the concept? The size is inversely proportional to the atomic number. Okay, the size is inversely proportional to the atomic number. Similarly, the others, chromium 3 plus and chromium 6 plus. So here the charge is different in the same ion. Therefore, what is the concept? Charge is minimum means more radius. Charge maximum less radius. Because of this a cation. So therefore the cation, okay, cation, what is the concept? The charge is inversely proportional to the size. So maximum charge, minimum radius. Therefore, this is a maximum radius. Chromium 3 plus is the maximum radius. Then chromium 6 plus. Okay. Yeah, students, write it. Don't simply say. Write it.